Alright guys, today we're going to be continuing our conversation around the 3 different types of decay. And before I show you how to represent it using an equation, I found this really strong example online that I wanted to share with you all. So let's just do a quick summary of what we learned yesterday. Alpha decay, it does emit that helium nucleus, or those 4 subatomic particles, 2 protons, 2 neutrons. So the generic equation is just going to be some element X with some mass and some proton number is going to turn into a new element. The mass is going to decrease by 4 and the proton number is going to decrease by 2, because remember, 2 protons and 2 neutrons leave that as an alpha particle. So we have a new element with some new mass and some new proton number, as well as that alpha particle. And here's a really strong visual of that actual decay. So we start with a parent. He has too many protons, turns into that daughter, and releases that alpha particle. So we did talk about 2 different types of beta decay, but we are just going to mainly talk about the regular beta decay, not beta positive decay. We're going to be talking about the beta decay where a neutron turns into a proton. So that's normal beta decay. So we do emit that beta particle, and we start with some element X, and we actually gain a proton from this. The mass stays the same because that neutron turns into a proton. The proton number goes up, and we need to signify that. It does change its element, but the mass stays the same because neutron and proton both have mass. The mass will remain unchanged. Plus, we're also going to have a product of that beta particle, which is, remember, that electron that gets emitted, as well as that change from neutron to proton. And here's another strong example. We have that parent, and the 1 neutron turns into a proton on this side. And I don't know if you can really see if you zoom in, as well as that beta particle, which is just that electron. All right, gamma emission. We're not really going to practice any problems with this because you'll see in a second. Remember, gamma particle doesn't change the element. It's just a super, super excited atom. And this is what it emits, a gamma particle. Notice how it's 2 zeros because nothing changes. We start with element X in its excited state. We end with element X not as excited, and that energy getting emitted. So here's my parent. Daughter and parent are the same. We just lost a ton of energy. So those are our 3 radiations. We're going to do examples for both alpha and beta reactions today. So let's start with our, and I noticed you can see through it. Sorry guys. Tried to improvise. Let's start with just alpha decay reactions. So remember, we have too many protons. We're going to emit an alpha particle, which is just helium. So we're going to emit 2 neutrons, 2 protons. So I take this, I'm going to write in my helium, and I'm always going to signify that 4-2. And then whatever I subtract here, I'm going to subtract from that top number. So I have 4 here, so I got to get rid of 4 here. 222 minus 4, and you can see through, is 218. But you also have to subtract 2 protons because they get emitted and turn into that alpha particle. And I'm going to circle this here. Alpha particle. And then we have a completely new element. So I take 88, I subtract 2 from that. I have 86. And then I double check my periodic table. I look for 86. And I see I am now, let me pull this up for you guys. I am now radon. So I'm just going to signify that with its elemental symbol, and then I was going to reveal the answer and double check my work. This is what it should look like. So you start with an element that has too many protons. It's unstable. It wants to get rid of that alpha particle. Once it gets rid of that alpha particle, it changes into a new element because it got rid of those 2 protons And now you got rid of that mass of 4, so you have to subtract that from the original mass. Let's look at another one. We have palladium this time. I talked about that yesterday a little bit. It's going to undergo alpha decay. How do I signify that? Well, the first thing I always do is I get rid of my alpha particle because I know that gets emitted. So my alpha particle is just helium. So I got rid of those 2 protons, 2 neutrons. So I got rid of helium. And then I just like to look at this. Whatever I see here and here, I subtract over here for my alpha decay. So 208 is at the top. I'm going to subtract 4. 208 minus 4 is just going to be 204. Then I look at this, 84. I'm going to subtract 2. I should get 82. And then I look at my periodic table. And I look for element that has 82 protons to tell me my identity. And I see that I am Pb lead. And really not as effective. Post-it. Yes, I was correct. So this is what your practice problems are going to look like. So I wanted to show you without having to rip away a Post-it. So let's do the same thing. So I'm going to tell you that these 2 elements are going to undergo alpha decay. So you're going to just draw your arrow signifying a change, alpha decay. The top is going to go down by 4 because you're losing that mass of 4. So 256 minus 4, 6, 5, 4, 3, 2. 252 is going to be at the top. 103, remember you're losing 2 protons, and top number is always mass, bottom number is always proton number to tell you the identity. 103 minus 2 is 101. Then you go to your periodic table and you look for LR. Well, no, you look for 101. So 101 is going to be, where are you at? Mendelevium. Sorry guys, I realize I'm way off with my camera. So MD. And then you can write your alpha particle. Or you can do it the way that I showed you in my example, where I tell you it undergoes alpha decay. Before you do anything, you do your 4,2 helium plus, you just kind of go across and you're just going to subtract from the top. So 231 minus 4, 31, 30, 29, 28, 27. 227 is my new mass, 91, 90, 89 is my new proton number. And before I write my element, let's look for 89 on the periodic table. And he is actinium, right here, AC. And that is how you represent an atom that undergoes some kind of nuclear reaction. All right, let's do a beta example, and then you guys can jump into your own practice. So let's say carbon undergoes beta decay. Nothing changes in my mass. So mass number remains unchanged, but I do emit that beta particle. And remember, the beta particle is just that electron that I'm getting rid of. So I'm going to get rid of a 0 and 1 electron, and this is just how you show that you got rid of an electron. Remember, this isn't a proton this time. It's just that beta particle. So the only thing you change about this is not the mass, just the proton number. Remember, your neutron becomes a proton. So you're just going to add 1 here. So you are now an element with 7 protons. And you are nitrogen. And let's just double check. I think I wrote it backwards. That's okay. So you're now nitrogen. Remember, you have the same mass. This should never ever change. You should just gain that proton. And you always have to signify that you got rid of that beta particle, that electron. Let's do another. I'll do it the opposite way, the way it looks here. Let's just keep the mass the same and add 1 to 53. I get 54. I have to look at my periodic table to see what 54 is. It looks like I am a noble gas of xenon. And I'm going to add in my beta particle to signify that I lost that as well. Double check. Perfect. You're just going up one element on the periodic table, but you do need to signify that with numbers. I'm going to provide you a positron example just so that you guys know. I'm not going to ask you any of these questions. Let's just take carbon again. So let's say it goes through beta positive decay. Well, I know that I emit a positron, so that's an anti-electron, so I'm just going to signify that with a +1 as opposed to a -1. And in this case, I lose a proton because my proton turns into a neutron. Again, the mass remains unchanged because they're just flip-flopping. But my proton turns into a neutron, so I actually go down an element, so it's -1. And if I look at 5 on the periodic table, I turned into boron. So again, this is just an example for the 2 different beta decays. I'm only going to hold you responsible for these ones, but I did want you to see the other one. All right, let's practice how I'm going to ask you to do it. So let's say I want you to show me that both of these guys undergo beta decay. I start with helium. I know my mass remains the same, so I'm just going to write the number up here. I know that I gain a proton since my neutron turns into a proton. So 2 + 1 is 3. What is 3 on the periodic table? Oh, look at that. I turn into lithium, but I also need to show you that I emitted that beta particle. All right, let's try sodium. Remember, mass stays the same. I just gain a proton. 11 + 1 is 12, which means I am now magnesium. And I emitted a beta particle. If you guys need any help or you have any questions at all, please reach out or come to office hours. We're pretty much just going to be doing decay all week, and then we'll have a little bit of a review on fission fusion, and then I will test you on these concepts. Good luck.